Okay, so we're going to look at the ambiguous case for the sine law. So it involves a case where you're looking for an unknown angle. So in this particular diagram that I have here, we're looking for this angle. Okay, so we're looking for angle C. And when you go to do the calculations, you'll see why we call it an ambiguous case. You're going to get an answer that won't make sense to the diagram. And we'll see how that comes about. So we're going to apply the sine rule as per usual, and then you'll see where this ambiguous case comes from. Okay. So let's do our normal sine law here. I look for the side where I know both the angle and the side length when I'm dealing with the sine law. So in this one I know angle B and I know side B. Okay. So here's my corresponding side B. Okay, so I'm definitely going to be using that. So I'm going to be using B over sine B. Set that equal to, well, the side and the angle that I'm looking for. So I'm looking for angle C. So it's going to involve that, and that will be over side length C. Okay, so let's go ahead and solve that, or plug in our numbers. Okay, so if we plug in our numbers, B is 7 over the sine of 20 degrees, okay, and that's going to be equal to my C, which is 10, so side C, which is 10, divided by the sine of angle C, which is what I'm actually looking for. Okay, so this becomes 10 over the sine of C. So that's what I'm looking for, is that angle C. We do our cross multiplication here, so cross multiplication. So 7 times the sine of C is equal to sine 20 times 10. Okay, so there's my multiplication all set up. You actually multiply out the right-hand side, so in your calculator you're going to do the sine of 20, and the TIs, remember to close your bracket, okay, multiply by 10, okay, and you get that 7 times the sine of C is equal to 3.420. Okay. So now in order to solve for C, I have to divide both sides by 7, and I'll just bring my work up here. That'll cancel that out, and I get that the sine of C is equal to 0.489. 0.489. Okay? And if you remember from class, we said that that's the sine of C equals that. And a lot of the people that I find that make the mistake will say, well, my angle C is 0.5 degrees, which is obviously wrong. And so this isn't angle C, it's the sine of angle C. So we're going to use our calculator and do the inverse sine to have our calculator tell us what angle, when you take the sine of it, gives you 0.489. Okay, so on our calculator I go inverse sine of my 0.489, and I get 29 degrees. Now, if you weren't thinking about it, you would just fire that into your diagram and say 29 degrees. So you'd put the 29 up here in your diagram. Okay. So you'd say, all right, 29 degrees. And if you'd never heard tell of the ambiguous case, you would sit back and say, well, my answer doesn't seem to be right for my diagram. If I look at it, I've got a really small angle here and 7, and then I have a really large angle here. Okay? And by the diagram, it's obviously much larger than 90 even. So something's going on here, right? 29 can't be my answer. Okay? And we're going to see how it sort of is your answer, but you have to adjust for what they call the ambiguous case. So we'll flip this over. And we'll come back to it. Alright. Triangles, we only have to worry about 0 to 180 degrees. Okay, and we'll put in the 90. Okay, and sine is opposite over hypotenuse. Okay, so if we stop and say, okay, there's sine over hypotenuse, let's take and make an arc here that's, I'll try to make it as close to the same all the way around. Okay, so basically a semicircle here. And we'll pretend that we're going to make some angle inside of that semicircle. Okay, so let's make this angle, say right here, inside that semicircle. Okay, and then we'll say, alright, let's make a triangle out of it like that and say, well, what's the opposite over hypotenuse? Okay, well, here is your opposite side, and this is your hypotenuse. And everybody could agree, if you looked at that, that's probably around 30 degrees. Okay, so you're saying, well, how can I have the same answer for opposite over hypotenuse, but a different angle from 30 degrees? Well, let's look on this side of the arc over here. Okay? What if I took that same hypotenuse and shifted it over here? My hypotenuse is obviously the same because it's the same line. You're just making the same line and shifting it over. So there's my hypotenuse. And if I drew this super accurately, you would see that this opposite side length is the same here and here. But my angle is no longer 30 degrees. Okay? Well, you say, well, what is it then if it's not 30 degrees? Well, this angle in here would be 30 degrees, the same as the one from here to here would be 30 degrees. Okay, but this is the true angle of this line right here. Okay, so you say, well, what is it? Well, if this is 180 degrees right here, my straight line, and I've got 30 degrees between my reference point and my line, then that must mean from 0 to here is 150 degrees. Okay? So basically, whatever my calculator gives me for an angle, my calculator always gives me the first quadrant angle for my ratio of my opposite to the hypotenuse. But for sine, there's really two possibilities. There's one that's in the first quadrant, and you have another angle in the second quadrant where it's 180 degrees minus whatever the first quadrant angle was. Okay? So a 30 degree angle has a sine value, okay? And then 150 degrees would have that same sine value. So let's flip back to my triangle. Okay, so we said, well, 29 degrees doesn't make sense, right? But if I go 180 minus 29, which gives me 151 degrees, that does make sense. So now my angle C equals 151 degrees. That does make sense to my diagram. Okay, so that's the ambiguous case where you get an answer when you take the inverse sine. Okay, and then you have to look at your diagram and see, is it the answer that the calculator gives me, or is it the second quadrant, this quadrant angle, the one that's closer to 180? Okay, so let's just for a second, okay, if you look here in my, hopefully you can see it in the calculator, there's my answer that I got. Okay, and if I go the sine of 151, which I'm rounding off, right? Okay, and then I hit enter, okay, you get a really similar 0.485, okay, which is a really similar sine ratio. So you can see the sine of 29 and the sine of 29 degrees. So sine 151 and sine 29 both give you really the same answer. Okay? And that's your ambiguous case. So when you're doing a question, just remember to look at the diagram and say, well, I got an angle that doesn't make sense for the really big angle that I've got, so maybe I've got the ambiguous case. Okay? So just keep that in mind when you're doing one of these problems.